All right, brand new chapter, brand new marking period, only one marking period left. Not sure how much we'll get done. I mean, we'll definitely get done chapter 7. Hopefully we'll get into chapter 8 by the end. I would think we would. But anyway, let's just concentrate on this right now. What? It's like the 21st or something like that. I forget the exact day. Let me see. Spring. Okay, Easter, or Good Friday is the day that we have off. That's our first day off, and that's April 18th. So April 18th, and today is the 24th. So that gives us what, like 3 weeks? Okay, 3 more weeks until Easter break. And then after that, we only have like 2 weeks, maybe 3 weeks before school's over. All right, so there's not much time. All right, here we go. Let's talk about what it means to find the area of something. Let's do probably the simplest one that we're going to do, and that would be the first one, which is a rectangle. All right, so here is a rectangle, and what I want to do is find the area of this rectangle. What does that mean to find the area of a rectangle? I'm going to try my best to break it up into a bunch of squares. All right. We'll see. This may not be perfect. Well, I know it's not going to be perfect, but maybe like this. Bring that down a little bit. And maybe like this. There we go. They kind of look like squares now, don't they? Yeah, some of them look more rectangular-ish, but again, I'm just kind of doing this by sight, all right? Like that one definitely looks different size than that. Pretend. Let's just do a little pretending that they're all squares inside of here. Everybody, can you do that for me? All right, so pretend they're just a bunch of squares. They're all the same length and they're all the same width. By the way, that's what we call this. Well, sometimes we call it that. A lot of times we'll call this the length, and it doesn't really matter which one's the length or the what. What was the other word? The width. All right, so it doesn't matter. A lot of people think, oh, always the up and down one is the width. Some people think always the one that goes across like this is the length. It does not matter which one I call the length, which one I call the width. There's another thing that we're going to use, okay, and it's called the base and the height. So I could call this the length, or I could call it the base. I could call this the width, or I could call it the height. What we're going to do in here is we're going to use base and height more than length times width. The reason I put length times width is because a lot of times, I mean, Mackay said it. I said, give me the area of anything. And he said length times width. And that's a very popular way of referring to this. I mean, teachers teach us all the time. There's nothing wrong with it. It's perfectly fine. But when we start getting into more shapes, okay, more polygons, we're going to start using base and height instead of length and width. Is that all right? Okay, so I'm going to use base and height. So one of the sides is the base, the other is the height. So what are you doing when you're finding the area? I'll just put A equals. You're finding how many squares are inside of that particular figure, all right? So you could sit here and do what? You could count them all, couldn't you? 1, 2, 3, 4, 5, 6, 7, 8 this way. And then I could go another 8, another 8, another 8. I could add up all those 8s together. But what do you think is a better way, since you got rows and columns right here? If I got 8 of them across this way, and I got how many down this way? I got 4 down. Instead of going 8 plus 8 is 16, plus 8 is whatever, 24, plus 8 is 32. Instead of doing that, what's an easier way to do it? Just go 8 times 4. That's right. So I've got 8 this way. I got 4 this way. Just go 8 times 4. So really, what is that? This 8 is the what? It's the base. And what is the 4? Is the height. So I could go base times height. So that is our formula. Okay, that's how we're going to remember the area of a rectangle. You might have remembered it length times width. It's perfectly fine. Nothing wrong with that at all. But for what we're doing, what we're going to do a little bit later, it's probably better to say base and height. Now, when I talk, what's that? Pen. You going to give it back to me? It's my only black pen, so make sure I get it back. I'll hunt you down. All right. So, what I was going to say. Oh, the base and the height. Now, here's something that they don't usually tell you in like your middle school class or something like that when you probably learned about area. The base and the height have to be perpendicular to each other. What does that mean to be perpendicular? If they're perpendicular, what must be true? You must have a what? What's that angle right there? A right angle, okay? So the base and the height always have to be perpendicular. You hear me on that? I'm going to even write that in here so that you have it in your notes. So the base and the height have to be perpendicular. Because you're going to see some stuff that may not look like it's perpendicular and you may think is the base and the height. The base and the height have to make a 90-degree angle. They have to be perpendicular with each other. All right, that's super, super important. Make sense? Yeah. So that's how you find the area of a rectangle. Well, what's another kind of rectangle? A rectangle with all the sides equal to each other.
Square.
It's a square. That's right. So that's a square. That means all these angles are right angles. You could just say that this side right here is the base, couldn't you? And you could say this side right here is the what? Is the height. And that would be perfectly fine. So you could say the area, I'll put a little S right there. What do you think that S indicates? Area of a what? A square. The area of a square is equal to the base times the height. So you could write it like that, and that's perfectly fine. This book does this. Well, not just this book. A lot of books do this. Thank you. Thank you. All right, your seat is Sincere, you're behind Alani, and Abdul, you're behind Penny. All right. What was I saying? Okay, back to this. A lot of times they do this. Instead of calling this the base and the height, this is when we're dealing with a square. Okay? A lot of times they'll call that S. Why do you think they call this S? It's not because of square. It's because of the side. That's right. So what's true about a square? All the sides are equal. That's right. So every one of those would be S. Would you agree? So that's why a lot of times they don't show it as B and H, because the base and the height, they're two different letters. So people might think that they're two different numbers. But when it's a square, what's true about both of these numbers, the base and the height? They're exactly the same. They're equal to each other, right? So here's another way that you might see it. This is perfectly fine. If you want to remember that the area of a square is the base times the height, I'm fine with that. There's no big deal. But here's another way that they say the area. Again, this is the area of a square. Instead of base times height, you could say what? Side times side. Or what's anything times itself? Side what? Squared. Good. So you could say the area of a square is just the sides squared. All right? So for instance, what if that side was equal to 3? How can I find the area of that square? Yeah, 3 to the second power, 3 squared. What's 3 squared? It's just 9. Everybody with me on that? Let's go back to this rectangle. Almost forgot. Ooh. Let's say this was in centimeters. That was 8 centimeters. And what did I say this was? That doesn't look like a very nice 4. Let's make it look a little bit better. So that's 4 what? Centimeters. So now watch very carefully. Let's do the math on this. So what is the area of this rectangle? Never did find the area of the rectangle, did we? The area of the rectangle is the base times the height. What is the base? 8 centimeters. Times the height. What's the height? 4 what? Centimeters. That's very important for what I'm going to show you right here. So you do the 8 times 4. That's easy. What's that? That's 32. But watch very carefully. It's centimeters times centimeters. So how do I write something? You got it. Centimeters squared. Okay? That's very, very important. Okay? So the units of area are always what? Squared. Okay? Why? Because you're finding out how many Squares are in that particular polygon. You understand that? So this says I have 32 square centimeters. You'll see that a lot. If you ever go out, you probably wouldn't go out on your own at this age, but I don't know, maybe you're getting new carpet or new flooring or something like that in your house, and your mom or dad say, come out with me, we're going to get new carpeting, or we're going to get a new floor for our kitchen or whatever. All right, and you're like, oh, come on, do I really have to do this? Anyway, you go out there and you'll see the prices. You'll see like $3 per square foot, and you'll see it like this. You'll put like square, and then it's usually in square feet. You'll see that right there. So that's supposed to be a dollar sign. Looks pretty bad. Let's make it look a little bit better. I have no idea what carpet or flooring is. It's probably way more than $3 a square foot. Who knows? I don't know. But $3 per, right? That's that slash right there, per square feet. But a lot of times you'll see it SQ, and then whatever it is, square centimeters, square miles, square feet, square yards, whatever, okay? But that means the same thing as what? Feet what? Squared. So this and this mean the same exact thing, all right? You've heard that, right? Somebody talks about like how big your country is or how big your state is. You measure it in what? Square miles. You ever hear that before? Yeah, you've heard that. So you could put SQ, but really mathematically, we're going to put feet squared or miles squared or centimeters squared. It's very important that you include the units, all right? Everybody see that? So area is always something squared, okay? All right, enough of that. So what about this? What if this was 3 inches? Everything was in inches. This would be 9 what? Inches squared, okay? So make sure you don't just put a 9. Just don't put 9 inches. 9 inches is just a length from point A to point B. We're trying to find out how many squares can you fit inside that big square. Well, you can fit 9 of them if each side was 3. Make sense? Ben, you taking good notes? No, you're not. You're not doing anything, okay? Well, that's your fault, okay? You need to come prepared. What am I supposed to do about that? Hold your hand through every single day and give you stuff? No. All right, enough of that. Let's go to a parallelogram. That was the next thing on the list, wasn't it? All right. And the nice thing about a rectangle, a square, and a parallelogram is the equation or the formula for it, the area of it, is exactly the same. So what was the area of a rectangle? What was the formula for an area of a rectangle? We just did it. Base times height. Let's say it like that, okay? BH is fine, but base times height is how we say it. What's the area of a square? Okay, well, it's not a squared. It's just base times height. Or you could say side squared, okay? But you got base times height. You got another base times height. Guess what the area of a parallelogram is? Look, I was trying to get you somewhere. Thank you. Okay? Follow my reasoning. All right? If anybody does this, look, the first one was base times height, the rectangle. The square was base times height. So what do you think the parallelogram is going to be? Base times height. Very good. Do you see my line of reasoning here? All right. So this is also going to be base times height. But what did I say had to be true about the base and the height? They got to be perpendicular. Do you see any perpendicular lines here? No, you don't. There's no perpendicular lines here. Nothing's perpendicular. All right. So if I considered this to be the base, I'll just put B. If I considered that to be the base, don't write this down, okay? This next thing I'm going to write. Is that, put a question mark, is that length right there the height? It's not. Why not? It's not perpendicular to the base. Very good. That's exactly what I wanted to hear. All right? But here's what they're going to do a lot of times. Sometimes they'll give this to you. Sometimes, I don't know, they might make you find it. All right? I doubt with the problems that you're going to do, they're going to make you find it. But watch this. What would be perpendicular? From the top, perpendicular, or a lot of people like to say straight down. I don't really like that too much. But this red one right here would be the what of the parallelogram? Well, it's perpendicular, but it would be the height of the perpendicular. So, is this the height? No, that's not the height. That length of that side is not the height. It's this one is the height. Which one is the base? The base goes all the way from here to here. Everybody see that? So that's the one thing that's a little bit more confusing about this compared to a rectangle or a square, right? And most of the time, I would say most of the time because I'm not 100% sure, but most of the time they'll probably give you the height. Okay, they'll give it to you. But they might give you this length as well. But am I going to use that number? Okay, no, I'm not going to use this number for the height anyway. Okay, I'm not going to use this number right here. I'm going to use this one right here. And of course, this is the base. Well, this would be considered the base as well, wouldn't it? Right? Because remember on a parallelogram, the opposite sides are equal to each other. So it's either that could be the base or that could be the base. This could be the height. You could have a lot of heights in here, couldn't you? You could go from here perpendicular to there. You could go from here perpendicular to there. Here's another thing they could do. Watch this. This is kind of weird. They extend this side out right there, and then if you extend that side, guess what? You could go from the top perpendicular to there, so that could be the height. Every single one of those red vertical lines right there are the height of your parallelogram. Okay? Sometimes they'll put it outside of it like this, but they usually have a dotted line to extend it. That doesn't mean that your base goes all the way out to here. Your base is still from this point to this point. Make sense? All right. So that is a parallelogram. So that was pretty important. So again, let's write it down. What is the area of a parallelogram? It's just what? My pen would, right? The base times the height. Okay, and that's how you find the area of a parallelogram. Should probably write the word parallelogram. I should probably write it. Okay, so this is all parallelogram. All right? Or you could put a and then like a little P right there. What does that mean? Area of a what? Parallelogram. Okay? All right. So far it's been pretty easy. Every single equation or formula, we'll call it a formula, every single formula for area on a rectangle, a square, and a parallelogram have been the same. But it's not always going to be like that. All right? Check this out. What was the other figure we were going to talk about today? A triangle. So what I'm going to do is I'm not going to draw a triangle right now. Okay, I just want to show you something. Say what? I don't know. Yeah, anything I put on here. Anything I draw, anything I write, you should write down. So watch what I'm going to do. That's a rectangle, isn't it? But check this out. I'm going to go from this corner to this corner. That's a diagonal. Remember that? So what was the area of that rectangle? It was the base times the what? The height. Okay? That was the area of the rectangle. But what do you think? Oops. Come on. There we go. This is shading in, okay? I'm shading this in. That's what all these lines are. Okay, I'm shading in that triangle right there. Everybody see that triangle? How much of that rectangle is that triangle? Or that triangle is how much of the rectangle? How much? Say what? 50 what? Percent? What's an easier way to say it? It's half of it. Exactly right. It's just half of it. You are right. It is 50%. That is half. But it's a lot easier to say half. So, get this. We could come up. This is a triangle. At least the part that's shaded in is a triangle. So what do you think that the area, I'll put a T right there, meaning triangle. What do you think the area of a triangle is then? It's half of the rectangle. Would you agree? Yeah, that triangle right there is half of the rectangle. So what could I do? I could go base times height and then do what to it? Divide it by 2. Thank you. See what I did? So we actually came up with a formula on our own. You drew the rectangle, you split it in half, and you said, oh, that's a triangle right there. And is this perpendicular? Yeah, because I started off with a rectangle. That must mean that's a right angle. So the area of a triangle is what? It's the base times the height. Talk to me. What else? Divided by 2. Very good. Or some people write it like this. Instead of divided by 2, you guys said take half of it. So you could write it as a half. Half of what? Base times height. Again, what are we finding? We're finding out how many squares can you fit inside of that triangle, right? Now, if I start drawing a bunch of squares, watch. Let's do this in a different color. Make it pop a little bit. Watch, if I start drawing a bunch of squares, let's say I start here, and I draw it to here, and then I draw a square like this. You see what I'm doing? Just trying to draw a bunch of squares. I don't know if it's going to come out even or not. And it's close, not perfect. But you get the idea. But you're going to have all these little leftovers. That's not even a square, is it? But you're going to have a whole bunch of these little leftovers, all right? And you're going to find out how many squares actually fit inside that triangle. That's what you're doing when you're finding the area. How many squares can you fit inside of a triangle? All right? And that's what you're doing. That's what you're doing when you find the area. So, let's do a couple examples. Yeah, let's do a couple examples. Let's just make up an example for this. Let's say the height is, I don't know, what does that look like? 4. This looks a little bit bigger, so we'll call that 6. That base is, let's call it, it doesn't matter. We'll call it 6, okay? So how do I find the area of just that shaded in triangle? I go base times height, 6 times 4, and then what do I do with that? I can get a pen that writes, divided by 2. So 6 times 4 is 24, divided by 2 is 12. I didn't put the units. What's your favorite unit? What is it? Inch. Okay, so 6 inches. I almost put millimeter. Excuse me. All right, so what's my unit of my answer going to be? Is it just going to be 12 inches? 12 inches squared. 12 inches squared. Listen, do not, everybody hearing me? Do not square the 12. Okay, your units are the only thing that's being squared. It's just inches squared. Don't put 12 squared, inches squared. Everybody hear me? That's something I've seen students do a lot. Okay, I never even would have thought about that until I saw kids doing that. All right, you don't square the 12. It's just plain old 12. 24 divided by 2 is 12. But then you take the inches and you square the inches. That's how you should write your answer. Don't just put 12 inches. Don't just put a 12. All right, if they give you units, and sometimes they don't. They just give you numbers. Well, you don't have to put any units then. Sometimes they'll do this. Let's say they didn't put any units on this. Let's say they just said that this was 6 and this was 4. You didn't know if it was inches or centimeters or feet or miles. You had no idea. So you do your work and you get 12. This is what they do a lot of times. They'll put units, okay, since they didn't tell you the units, they'll say units squared. If you look in the book, okay, if you do an odd problem, you look in the back of the book, you might see this, units squared. Or sometimes instead of writing out the whole word units, what do you think they're going to write? Just a U squared, okay? So if you see this in the book as an answer, that's what they're doing, okay? Because they didn't give you any units. If they don't give you any units, you put them in there, all right? And you just call it U, all right? It doesn't really stand for anything. It just means, okay, they forgot to put whatever the units were. But if they were in there, I would square the units. Okay, enough of that. Let's do an example. We're almost done. This hasn't been too hard, has it? Pretty easy. All right, let's draw a parallelogram. So this is an example that they have in the book. They call it example 2. Kind of done example 1 already. I just didn't talk about it. Let's see. There we go. Looks like that. And here's what they do. They tell you the length of that side is 25. They tell you the length of this side is 13. And then they do this. I'm going to do this in a different color. They go from here to about right there, and they say that's 10. And this is all in inches. So let's put that in there. That's 13 inches. That's 25 inches. This is 10 inches. And they do put a little right angle mark there. All right? And you have to find what? What do you think they're asking you to find? Find the what? Find the area. They're asking to find the area. So first of all, what kind of figure is this whole thing right here? What does it look like? And they tell you it's a parallelogram, okay? So they actually put A, B, C, D. A, B, C, D. They say find the area of parallelogram A, B, C, and D. All right? So we have a formula, don't we? What's the formula for the area of a parallelogram? It's just the base times the height. I'm going to write that in here so I remember. Let's put the base and the height in there. Now, you got to be real careful with this. Look what this one is right here. It's perpendicular to this side. You see that? So which one is base? Is it the 13 or is it the 25? Is it? No. This is this right here perpendicular to DC? Is this perpendicular to the 13? No. What is it perpendicular to? To BC, right? How long is BC? It's 25, right, because it's a parallelogram, right? The opposite sides are equal. So this would also be 25. So look, this is perpendicular. See where that little right line or that right angle symbol is? It's connecting this one to this one, right? So it's this is my height, this is my base. Make sense? Do we even use the 13? No, we don't even use the 13. Okay? It's got nothing to do with the area, all right? Because I don't know anything that's perpendicular to this. This D, whatever it is, letter, I don't put a letter, we'll just call it E. This DE is perpendicular BC. So that's your base and your height. That's your base and that's your height. And that's the trickiest part about doing this, is knowing which one is the base and which one is the height. So what do? 25 inches times the height, which is 10. We can do that in our head without a calculator, can't we? Yep. 25 times 10 is 250. What are my units? Inches what? Squared. And that is how we find the area. What does that mean? That means there's 250 squares that can fit inside of that parallelogram. That's what we're trying to do. How many squares can you fit inside of there? Well, if that side was 25 and that perpendicular line right there, that height was 10, that means you can fit 250 squares inside of there. Okay? All right. So one more thing I need to talk about on the triangle that I forgot. But I tell you what, let's do the example because I'm running out of time. Let's just do the example. And I'm going to draw a triangle. Like this. All right, so it is a triangle. And here's what they do. In the book and or on a test paper or something, you would make this a dotted line, but I'm just going to make it a different color. Just to jazz it up a little bit. All right. And they say that this is perpendicular. All right. And now, here's something a little bit trickier. Let's go back to white. They tell you that this is 12 feet. If they just put a 12 right there, where is it going from? Is it going from here to here? No, it's going this whole entire side of that triangle. Everybody see that? So if they just put a 12 there or 12 feet there, that means it's all the way from one end to the other. All right? And they don't tell you the yellow one. That's our height. How do I know that's the height if this is the base? Because they're what? No, they're not parallel. They're perpendicular. They're perpendicular. So if this is the height, then this would be the base, wouldn't it? Here's what they do. They ask you to find the height. But how are you going to find the height? Well, they tell you the area. So they're not actually asking for the area. They tell you the area. And they tell you it's 54 feet squared. So what you have to do is find the height. And that's what they are going to ask you to do. Find h. So what I'm going to do is this. I am going to write down the formula. Area. It's a triangle. So what's the formula for a triangle? It's base what? Times height divided by 2. Everybody see that? Let's put in all the stuff that we know. Do I know the area? Yeah, they tell me. They told me the area. Okay, I didn't have to figure that out. They told that to me. So what I'm going to do is put a 54 in for area. Do I know the base? Yeah, what is that? It's 12. Times what? H. Do I know h? Nope, trying to find it. Then what do I have to do? Divide it by 2. Okay? So now, what can we do? We can do a couple things. I would do it this way. What's 12 divided by 2? 6 times what? H. See what I just did? I just plugged in all the numbers that I knew. I don't know why we're packing up. We're not done yet. So now I got to solve for h. How do I solve for h? Should be easy. We've done this a million times this year. Divide by 6. Divide by 6. And what do I get? What's 54 divided by 6? You know that off the top of your head? 9, right. 9 times 6 is 54. So the height is equal to 9. It's not just a 9. We got to put the units. Is it squared? No. Why not? Right. So here's what you're doing. Here's what you're doing. You're doing section 7-1, and you're doing 1 to... Let me just double check. Hold on. Give me a second. Give me a second. Yeah, 1 to 19. Okay, that's your homework right there. Check RenWeb for the lesson plans. The lesson plans are up. Thank you. The lesson plans are up, so check RenWeb for your lesson plans for this week. All right, I do.